Good morning, everybody. Can everybody hear me? I'm sure you can. Okay, thank you for joining us this morning with the FluidSIM hydraulic and pneumatic introduction. And that we're going to just what we're basically going to do this morning is we're going to introduce FluidSIM to you, and not actually looking at the technologies, but we will be drawing some, making some drawings and drawing some circuits, and we will also be simulating and show you how to do that. So the point of today is actually just to introduce you, and when you actually do the course with us, we will take you through all the details and you will follow us one-on-one. So we will do something, you will have to repeat, and then we will do something, you will have to repeat. Then you build the circuit, we build the circuit, you build the same circuit. Then we simulate, you simulate. So you're going to have to follow us step by step within the course, and we will take you through how to use FluidSIM in that as well. But for now, we're going to introduce you to FluidSIM, and we are just going to show you what the power is about using FluidSIM, and also what you can do with FluidSIM. So this is FluidSIM. Can everybody see my screen? Just want to make sure. Davy, is my screen available? Can you see it? Or anyone else?
Yes, sure, we can see.
Okay, fantastic. Thank you very much. Okay, guys, so basically if you have FluidSIM, then this is the first page. As you open it, it will open up like this. Then what you will have to do is you will have to start with actually opening up a new project. But before I go into that, actually, I just want to tell you quickly, FluidSIM is a teaching tool for simulating pneumatics, hydraulics, electrical, electronics, or digital technique, and also have some EasyPort and PLC other graph set options available on the libraries. Okay, and then this was actually developed as a joint venture between the University of Paderborn, Festo, and Art Systems software in also Paderborn. That's all in Germany. Okay, so they were all working together to bring you the solution of FluidSIM. So FluidSIM can be used separately, or it can be used with the Festo training hardware. It's up to you, totally up to you. You can obviously use a lot of things practically, and also there's also on the PLCs, we might show you also that you can actually link actual PLC to your FluidSIM, and as you simulate on FluidSIM, you can actually see all your real-life components also following that sequence. Okay, so fantastic. So let's kick off and go into the FluidSIM, and we have a look at what we can see here. Okay, so if we have a look at the overview of the FluidSIM, you will see at the top there are many tabs available. So it's file, edit, insert, draw, page, execute, didactics, diagnostics, projects, view, library, tools, windows, and help. So if you have FluidSIM and you downloaded it, even if you buy the actual package, then you can also check for updates on the help. I also usually do that to ensure that I'm updated all the time. Like I also said before, is that the FluidSIM is actually, if you buy it, it's a once-off license. You do not have to renew a license every year. Once you buy it, you have it for life. Okay, so that license will last you for as long as you live, or down the family tree. Okay, so then just check for updates, and you can actually then register. So the system will check for updates when you connect it to the internet, and if there are any updates, then it will update that as well. Okay, so it will do that automatically. So there you can see my FluidSIM is updated to the latest version, the version number 5, and there's no updates available. Okay, so further on, we also have a look at the technologies that you can actually make use of within FluidSIM. If we click on the library here, you will see that the library pops up, and on the left-hand side, you have a lot of many tabs available that you actually can see that these are all the technologies that you can make use of. So the first one is pneumatics. If I open the drop down here, you will see there are a lot more valves and components available under pneumatics. The same with hydraulics. Here we can see there's quite a lot, even mobile hydraulics and different other things as well. And then we have two types of electrical here. So the IEC electrical controls there, that is for the International Electrotechnical Commission, and the electrical controls is from NEMA, which is the National Electrical Manufacturers Association. So it depends on your liking and which standard you would like to use. Mostly we at Festo, we use the IEC. There, obviously, if you're in manufacturing, then the symbols, you would use the NEMA symbols more on a frequent basis. Okay, and then we also have miscellaneous. There are a few other diagrams and so forth, and then also digital technology. And then the last thing is obviously, well, the digital technology. Just to add, this is to do with the electronics and PLC and that type of thing. So and then also graphic, which is a type of program language that you can use to program your PLC as well. Then also at the Festo, we have something called EasyPort, and you can use FluidSIM to connect. You can use it to connect to your actual components through FluidSIM. So you can build a circuit here on FluidSIM, and it will simulate whatever you have drawn here with the actual components connected. Okay, so the actual components would do the work, and you would see it simulate here while it's really happening in front of your eyes. Okay, fantastic. The next thing that we can also look at is there are libraries available. So this is the standard symbols library that you can see here. And then also you see there's a little tab on the left-hand side. If you click it, it closes it. If I click it again, it moves away. If I just take it away like that and I just put my mouse on it, then it will open. If I do not click and I take it away, the library away, then it will also disappear. So it will open and close as you use it. Okay, fantastic. Then the other thing you can also do, looking at the libraries, is you can add your own library. So yeah, I've added my own library, and we can also add you can also add your own library. So all you have to do is you go to library, create new library. It brings up a place where you want to get it from, or where you want to go search, and then you can just put the library and name, and there you go. So there we go. So now we have a library. Okay, fantastic. Okay, so what you can also do, once you have your library and you want to go to the standard symbols here, let's say we're going to drag some actuators in here. And here at the top, if you want to open a page here, a new project, you must click on the new tab to open up the new project. Or you can go to file and say new, and then project or file. Okay, so there we go. So now we have a tab. You can see there's a red line here going all around, and that's actually the page size. So we can bring our cylinder. Let's go to our library we just created. So now you can take this component, you can drag it back in. It will already have a name because it's a standard component. And then you just say, okay, so now we can see I've added a component in my library. Okay, I actually already added a library for myself, which is I just call it this library. You can see I also even have some circuits here, so you can draw circuits and bring them into your library and store them as is. Just to show you quickly, if I simulate this, this is a working circuit. Just to show you, I brought it in from the library and I can simulate it as is. There we go, and there we go. Okay, so this is just a logic circuit, but I'm not going to look at that now. I want to concentrate on the FluidSIM itself. Okay, that was just an example to show you what is available and that you can actually create your own test library or library. Okay, there is also another library that's available from Festo. So if you go and you add a new library, so you have to go and download the library from Festo on the Festo from the Festo website, and then you can bring it in here, and then all those symbols will be available on the FluidSIM as well. So then you do not have to type in all your names for your valves and that type of thing. It will already be named, and you, for the project guys, you can just easily get a component list based on what the circuit that you've designed. Okay, so what we can do now is we can also start to draw a little circuit. So I'm going to start with drawing a hydraulic circuit just to show you what we're going to do and how easy it is to do it, and I'll also explain some basic features that you can actually apply. Okay, so here we go. We have a cylinder, we just click it, we drag and drop, we drop it into the page. There we go. Okay, so let's go get some more components. So this is hydraulic circuit. I'm under hydraulics here. So we have an actuator. Now let's go get our supply elements. What we need here is a pump unit. Okay, so we drag and drop our pump unit. Let's bring in a few tanks, let's say 2, just for the sake of holding a circuit. Okay, and bringing in some components. And let's bring in a gauge. Let's say we're going to use a gauge for the hydraulic circuit. Let's make it 3 of them, just to be full of fun and to build a nice circuit that you guys can follow. And let's say we're going to go get ourselves a configurable valve. You can also choose a mechanically operated valve, and you can also choose a solenoid operated valve. Okay, so these are all different. If you use the solenoid operated valves, that would be within our advanced course. So then you would have electrical controlling the hydraulic systems to automate it. And then we also have the mechanical operated, but with the configurable operated valves, we can actually make it as we want it to be. Okay, so let's quickly look at that configurable valve, and let's create something on it. Okay, so if you double click on the valve itself, then you will see there's a screen popping up. It opens up, and you will see there are many different parameters and the tabs that you can actually open. Okay, so the one that will be mostly used if you do our courses with us, the main one will be the configure valve. That means we can change our valve to our liking, and that it will have all the features that we would like to see on it. The other thing that you also need to remember with each valve, you should be able to give it you would be able to give it a name, and you should give it a name so that you can actually follow what you are doing. So in this case, let's call it forward reverse, just to make or return, just to give it a name for namesake, so that you can see what I'm doing. So I'm going to call it forward return. That's the identification. On the left-hand side of the valve at the moment, there's nothing else as well on the right-hand side. So for the left-hand side, we go just to the bottom here, left actuation. For the right-hand side, we go to right actuation. Now, actuation means how are we going to activate the valve? And if we can do it in a few ways, we can do it manually, mechanically, hydraulically, or electrically. And then you can add some pilot or spring return. It depends on what type of valve you have here. You will see that the external supply at the moment is grayed out. Okay, so you will have quite a few options. And if you click on the drop down of manually, you will see there are quite a few symbols. Now, if you do the basic pneumatic and basic hydraulic course, you will actually go with us through these symbols so that you understand what they actually mean and how to use them in your circuits. This is for mechanically, so for limit switches and that type of thing, for hydraulics, and also for electrical. Okay, so in this case, we're going to stick to manual, just to introduce you to our circuits. These are the 2 different ones. So this is a lever, a normal lever, and this will be a detent lever. So let's say we take a normal lever, and on the opposite side, we want the valve to be able to return by spring. Okay, so there we go. So we have a 2-way valve. It's a directional control valve, lever actuated, and spring return. Perfect. So then after that, you've done that, you can actually just quickly click on OK, and then you will see, there we go, our valve is ready for use. The other thing that I just quickly saw now that I can also show you again, you can see there it is now orange here, or pinkish orange. And so that if that is the case, then it means it's going outside of your page lines. So you need to stay within your page if you're making drawings. So then you just drag it in and you bring it within the lines, and you can see it's actually working, and it's white. It's not pink or orange anymore. There we go. You can see that there's a problem. That shows there's a problem. You need to be within the lines. Okay, fantastic. So then the other valves we also would need for this valve, for this circuit, would be some pressure valves. If you guys attended the basic hydraulic course, you would have noticed that we said you need to have at least 2 pressure relief valves, one to protect the pump and one to protect the system, basically, which is your system pressure valve. Okay, so there we go. So these are the basic components we would need for a basic circuit to operate properly. Okay, so let's put these things together and we're going to create a circuit. What I also would like to show you before we put the circuit together is if you double click on the cylinder, you will see that this page pop-ups, and you can see there are many things that you can change. You can change the piston diameter, you can change the piston rod diameter, the piston position, maximum stroke, mounting angle. There's so many things that you can change to make it actually as true as possible to what you actually see in front of you on a real system. So there are many things that you can add to it. If you go to another tab here, user-defined properties, this is usually for the attribute, the value, and so for the drafting guys, the guys that draw circuits, and they would usually work a lot here, as well as under drawing properties. So the position and the scaling, you can scale your cylinder size as well. I will show that to you in another way as well. Then you can also apply an external load. So if you want to put a load on the front of the cylinder, you can give it a number, and you can test how it would operate in actual load, certain kilograms. Then there's also the force profile. It will show you the force that is actually being generated and what happens to the forces as your cylinder moves forward. Then there are something called actuating labels. Darby will take you through the basic, the electropneumatic part of this FluidSIM illustration, and then you will actually demonstrate what these actuating labels will be used for. I'm not going to do that now, but I would like to show you the units. If you use this, then make sure the units are in the correct unit before you start doing any work within this tab. Okay, then also the nice thing about FluidSIM is you can change your cylinder. So you can go to configure cylinder. You can go choose whether there should be cushioning, yes or no. You choose the piston rod and what it should look like. Obviously, you need to know the symbols so that you understand what they actually mean before you just apply. You can also choose whether it should be a single acting cylinder in either direction or a double acting cylinder. So it depends. You need to decide. You can decide. You are the designer, and you put this together according to your needs. So let's call this we'll just call this cylinder A. Okay, cylinder A, and I'm going to say okay. Fantastic. Okay, there we go. So here we have a cylinder. We have our directional control valve. Here we have our power pack, which is our supply or our source. And let's quickly open that, and you will see again you have component parameters, user-defined properties, and drawing properties. Now on this power pack, we can also we can go and set do a lot of changes. So we would like to see our units to be in bar, and I like to work in revolutions and liters per minute or liters. So that is all. You need to decide what will work for you and in which units you work at your workplace or at country. Okay, so you use the unit that you are with. Okay, so I like to make them all bar and all megapascal because hydraulics are quite high pressures. And this is similar value. So once I submit the pressure here will be indicating bar, and the delivery rate will be indicated in liters per minute. Fantastic. Okay, and then we can actually also give it a name if you want to. Let's give it a name just for namesake and to be able to illustrate. So let's call it power pack. There's our power pack, and there we go. Okay, so you can see the names. You can drag them around. You can put whatever you'd like to put them. And then this is pressure relief valve. So I call this pressure relief valve our system pressure, and we're going to use that to control our system's pressure and protect our system from maximum pressure. So again, we can choose our units. I like to use bar and liters per minute or MPa. There we go. And as you can see, it's again pink. Means I need to bring it inside within the red lines of the page. Okay, so next thing I need to do is I can connect my component. So let's give this pressure relief valve a tank so that oil can always get back to tank if the pressure builds up to a certain point, whatever we set here. Okay, then there we go. So our pump unit, it will supply oil to our directional control valve, which will decide which side of the cylinder should get oil. And you can also see here, when I do, just delete this again, what happened here is if I bring my valve to the front, just in front of the and in line of the other port, it will connect itself. But that is only available if you connect automatically, if that is switched on. If I switch it off, you will see there will be no connections made, and you will have to connect it yourself. To connect it yourself is easy. You just click on one port and you hold the mouse, the left click, and you hold and drag it. You can drag it wherever you would like, and you can just click it again. Okay, so there we go, and it's connected. Okay, so what we also see here is we have a tank port, so we go get our another tank line, and we can connect. Okay, so I like to work with automatic connected. Okay, obviously that would become a problem if you have too many components here, then, because in any component, once you start, if they are all on this page, then they would start to connect with one another, like that one just did now with the cylinder at the top here. Okay, so if I bring the cylinder back, connect both sides, the front and the back of the cylinder, and there we go. So now all that's left now is we need to connect our pressure relief valve to protect our hydraulic system, which is our system pressure. We're going to add some gauges just to add some names and numbers to our system so that we can monitor what's going on, and then we can test our circuit. This is the hydraulic circuit. So you can see it's quite easy once you get to know your system, and get to know where to find things on FluidSIM. Okay, so if I simulate now, you will see this will pop up if any open hydraulic connectors are open. In this case, we have a tank line which is not connected. So what we can do, if we really want to, we can block it just so that that message does not come up, but it's not necessary in this case. I just usually skip that. Because your tank line would have a line if that is the power pack that you buy with that option. Okay, but in this case, it's okay. Okay, but anyway, these two also go directly to this tank, and there you can see our system is working. I can see there's quite a few messages indicating in PSI. So what you can do, go to your gauge, you double click on it, and you change the unit so that they also show the same unit that you would like to work in. Like I said, now we're just working with low pressures, up to 60 bar, because we use it in our training facilities, which goes only up to 60 bar for safety's sake. And yeah, so let's see now. Everything will be indicated in bar. So there we go. See 35 bar, 35 bar, 35 bar, 0 bar. Yeah. Okay, so there we go. So once we simulate, you can follow the pressures, and you can also see how the oil flows. Like I've told you, if you attended a hydraulic course, oil must always be able to get back to tank. Okay, there we go. Then we can operate our forward return simulation and valve to simulate and see what the valve does. There we go. And as you can see, it's moving forward and it's moving back. Fantastic. So that's quite easy to do. And obviously, you need to understand the technology to use it properly. Then another thing you can do with on this circuit is also you can go to insert, and you can also insert a parts list. So I click the parts list, and there you go. You see, there it is. Here's all our parts. It's already here. So for the designers and for the guys that's putting circuits together and designing circuits, or the technicians wanting to design some circuits, or maybe draw a circuit based on an actual machine existing in your plant at the moment, then you can actually do that, and then you can copy it and print it, laminate it, and put it on the side of your machine so that it's easy to do fault finding. Okay, fantastic. So what you can also see here, there's identification here. You can see some of them have the funny names. Okay, so there you can see that's the description. So firstly, we have a double acting cylinder, and identification, we called it cylinder A. So the second one is a power pack. So have a look at the third one. This is just a number, but it doesn't show me which one it is. But if I click on it and I go to the third one, you can see there, it actually shows you what you're looking at. So now we can double click it and we can change, give it a name. Give it a name. There we go. Tank line. Enter. Next one. That's another tank line. and let's call it number 2, just so it doesn't ask for the same thing. Then you can, then the next one is gauge. So we can add the name gauge, let's call it gauge 1, and then we have the next one, which is gauge 2, and the next one is gauge 3, and these are forward return directional control valve. And obviously you can change the names as you would like. That's it, and then you can just say okay. There we have our parts list. So our parts list is here. As you do more things, you can also say there are connector labels, target ID, and target ID to and from. So this is all part of the circuits. Once you become more familiar with the FluidSIM package, then more things would be filled in as you add more things to your circuit. So I'll stop here in this case. And what the other thing we can also do here is we can bring in some under miscellaneous. There are something called a functional diagram. So I'm going to quickly create a functional diagram, and we'll just make something up. And here under properties, I can say how wide it should be. Let's say it should be 4 wide. There we go. So only 4 steps. And there we go. So now we can also draw in here. We can also change things inside. So in this case, we only have 1 cylinder. We only have cylinder A. So I'm going to do that. And we're going to make some drawings here to say that what we are looking for to achieve in our system. So I'm going to do that. There we go. And I'm going to drag it in here. I'll put it here on the side. Let's give it some text. You can also give it some text names. No, let me give that one. There we go. Okay, so let's say this is step. And let's say if you do the other courses with us, you guys will go this. There's a sequence course we will be running soon. It's all about sequences, and for this you will need to do the sequence course so that you understand what is going on. So let's call it sequence. I'm just going to call it sequence based on what I said now. Okay, there we go. So sequence, there is our sequence. This is the steps. It will be manually operated, and then we can also bring in the state diagram, which is going to show us what actually happens in our system. So basically what we can do is we can what we expect to see, and we can measure it against what we do see. I'm going to show you now how that is done. Okay, so I'm just going to bring it all together and put them all together so that you can see. This is also good for some guys that on the technical side, if you want to show something to your management and you would like to motivate something to do something in the workshop or in the factory floor or somewhere, then you can show that. Okay, so what I did here, I chosen the double acting cylinder and I chose position. It should show the position, and there we can see there was some action happening early on. Okay, because I've tried to, I just put it up together and I just created something so that you would see what it would look like if we had to open it up again. Okay, so there we go. And there we go. So once we simulate now, you would see that these things will actually be live. So there you can see there's a line and it's tracking now what I'm doing on the system. And if I operate the valve, you can see the timing and everything it follows together. And I want to see the same thing. Okay, so I will have to hold it a little bit less. But you can see that everything moves a bit slow. So what I'm going to do, I'm going to change the simulation factor again, so that it is in more in a real-time speed. And that we can do by going to tools again. We go to options, and we're going to go to simulation. And you can see slow motion factor. I'm going to make it 1:1 so that it actually operates as a real system, like a real system would. Okay, according to that speed and based on the liters per minute, the flow that you have here and the pressure set. Okay, so now there we go. So that's the actual speed. There we go. And I can see if the operator doesn't operate properly, we are not going to get the spike at the top. So because there's some delay in the spring, and the operator would have to time it quite well. Okay, so there we go. So there we go. Okay, perfect. So that there you can see is an actual real time. And so if you had an automated system, this would go up and down, and as the cylinder moves forward, because remember this was just based on position of the cylinder. So there we go, position forward and backwards. Going forward, it goes up. Coming back, it comes down. And there we go. So that's to indicate the position. So what can also happen is now you can pause it. This is a very good feature. You can pause it, and as is, you can go and say File, Export. So if you have a look here, you can export in different ways. So you can export as a JPEG, BMP, GIF, PNG, TIFF, WMF, also a DXF file for those the draftsman, and then also a PDF. So you can just say OK, and it will ask you where you want to save it. And yeah, so I'll just save it on my desktop. Okay, so for later, you can just open it up again, and it would be in this position. You would see it in this position. What's great about it is that you can actually use it for fault finding. So if you simulated the system at work and you tried to get to the problem, then you actually go and track things and see if you can figure out what happened on your system. So there's many reasons why you would use FluidSIM. Training is one of them. Another one is to simulate and to test new systems. And thirdly is to use it as a maintenance tool so that you can actually try and see if you can troubleshoot your system and see if you can figure out what went wrong on the system. Okay, so this is our hydraulic system, and this is basically what I wanted to show you on the hydraulics. Here we go. So let's close our hydraulics, and what we can do now is we can go to the pneumatics. Okay, so for pneumatics, I'm going to close this project. I'm not going to save it. Okay, let's go to pneumatics. Now we're going to say it's new again. I open a new project, and we go to pneumatics. We open the drop down. Here we can see we have more components that we can choose from, more tabs, and in each tab we can go find our system. So I'll try to make a little bit bigger system here. Design a little bit bigger one with two cylinders. So there's our compressor again, and our A service unit. The simplified one is easier to use for drawing circuits. And then we also need to control these cylinders. And also, again, the other thing now with the pneumatics, again, you can change the pressure that the compressor will supply. You can see the operating pressure. You can also change the unit again, the liters per minute, the gallons. So this I like liters. There we go. That's what we use in South Africa. And if you look here, there's your symbol again. Again, you have component parameters. Again, you can change all your units to what you want to use. I stick to liters per minute and bar. Okay, and then again, you can give it a name and label it air service unit. There we go, ASU. And also, then you can just say, okay, there we go. Okay, so there's a few components. Now we need to control our directional, our cylinders. We're using directional control valves. We're going to bring in 5 two-way valves, and we're going to modify them. I do not want them to look the same. So there we go. So you can see again, the connections happens automatically because I've activated connect automatically tab here, icon. There we go. And then we connect it. Okay, and then we can connect the number ones as well. We connect the number ones, and there we go. So the number ones, they would be pressure. So I'm pressurizing both valves at the moment. And then what we also need to do is we need to add exhausts on our lines, on our ports number 3 and 5. So I'm going to give them different exhausts just to be to do it a bit different, because we have 2 different valves here. So the one would be threaded, and the other one would not be threaded. So this is threaded and not threaded ports. Okay, so threaded ports means we can also add some silencers if that was a problem, if noise was a problem. Okay, so there we go. So now on this valve, let's say we're gonna make it. We go to configure valve again under the tabs, configure valve, and we make it manually operated. So a push button on the right hand side, of the left hand side, and the spring on the right hand side. Okay, so there we go. And then on the other valve, we would like to use 2 springs, 2 buttons. So 1 button on the left hand side and 1 button on the right hand side. There we go. So there you can see it's the same valve, but we changed the actuation methods and the reset. So this is actuation a button, and reset is a spring. Here the actuation is a button and the reset is a button. Okay, so then also what we can do on this circuit is we can also again go to our measuring equipment. Then we can add some gauges and more to see more things happening on the circuit as well. So now in this case we have 2 cylinders, and we connected 2 cylinders, and we can operate them separately. What Davy will do with a circuit like this is he would automate it for us, and he would make it work faster or more in sequence. Let me rather say it like that. And then so let's simulate. If I go forward here and I reach the pressure I would like to see, then I can push the other button. There we go, and you can see the 2 buttons on this one. This is a memory valve, and this is not a memory valve, because this valve remembers where does not remember where it was. It always returns because of the spring to where it started. Okay, so this is a normal valve, which is a spring return. This valve has got 2 buttons, which is a memory valve. It remains in the position, the last position where you sent the signals from. Okay, so there we go. So obviously, again, you can change these valves. You can choose other things, other ways to operate manually. Okay, so if we go to configure valve again, you can go choose something else to operate. So you can have a foot pedal, a lever, a push button, or something. Just call it a general symbol for anything manual actuation. Okay, so let's just leave it as a push button, and there we go. Okay, fantastic. Are there any questions from anyone? Davy, are there any questions at the moment? Guys, remember, you will have to, we're going to take you through this. We are just introducing it to you today so that it's not new. Because if things are very new, you're going to struggle to keep up with everything, because everything is new. The technology is new and FluidSIM is new. So it's good that you just see it now and see how easily things can be done, and are not scared of FluidSIM itself, but rather learn to use it properly with us in the course, and step by step. And as we do, you do, and you follow us to learn more about how to use FluidSIM properly. Okay, so again, I just want to make this bar. Yes, Davy.
Sure. There is a question, yes. But I think I've missed the place where you've Michael have asked, good morning. I'd like him to please repeat this table. I assume that will be the motion step diagram table.
Or is it the part list? Is it
maybe the part list also? You can quickly repeat that.
I'll just put that all in on the circuit then. Okay, so we can insert, go to insert, you go to part list. If you want to add the part list, you can just click it there, and all your part comes in. Okay, and what we can do here is just on the part list is to bring it in again closely. Okay, and there we go. Okay, so then we can also add the other tables. So let's have a look at the function diagram table. I can bring it in, and I can just double click on it, and I can make changes to it. Okay, that is, I got it under miscellaneous. Then also the other thing that you can bring in is a state diagram, and that will also show the state of the circuit. Okay, now you can see now I have a problem here on my FluidSIM. It's actually becoming too big. So what you can do is you go to view, and you go say fit to window, and it pops all into one window, and you can see everything again. Okay, so that's what it is. That's how it operates. And like I said, this functional diagram we just use to draw what we want the system to do, and in the state diagram will actually show you what happens. So you just double click on it, and you can go say what you want to add, and now what components you want to add. Obviously, I just only gave one name, so that will be available. I need to give more names. So let's call this one MCV, and let's call the other one also, give it a name. Let's just call it as well MCV just for now, and then we'll just give our cylinders a name. So cylinder A and cylinder B, so that we can actually choose them if we want to see one of them simulating here at the bottom. So A and B. So again, under miscellaneous, you will get these diagrams. Okay, so again, I say view, fit to window. It all fits into the window, and I can simulate and look at what happens. Okay, I need to add some identification here. Okay, so just click here. We add a cylinder, for instance. We want to add the cylinder A. Cylinder A, there we go, 1A. And we want to see only position. If you want to see more, you can add more. But I just like to see the position most of the time. That's the most important part for me to see. And there we can see what happens if I operate. It comes up and shows it real time. Okay, so all the diagrams, most of these diagrams, they come from the miscellaneous tab. Okay, so miscellaneous tab. And for the Festo guys, you can also bring in, if you work for Festo or do a project on Festo equipment or something like that, you can also add a logo or a bitmap picture there. Okay, and there we go. That is what I wanted to show you guys, just as a start off and a kick off and an introduction to what can be done in FluidSIM. That's regarding pneumatics and hydraulics, just some basics. And some Darby will take you through some of the other tabs here, just to also give you an overview of that. Darby, are you ready to take over?
Yes, sir.
Okay. Are there any other questions before I go? Are there any questions from anyone, Darby? I see Peter
No,
Kiryu has got a hand up.
There's no questions.
Peter, you have a hand up.
Yeah. You see, Michael said what you have explained to him, that's exactly what you want. He said, thank you.
Okay, fantastic. And Peter, who's Peter? I see his hand is up, Darby. I'm not sure what he wants to know. Can you just unmute him maybe on your side?
Okay, hold on for me.
Just underneath attendees.
Peter,
his hand is up. Peter.
Is he unmuted? He can talk. Peter, you can.
Yes, I can hear you.
Okay, Peter, what would you like to know?
Yes, I would like to know how we can make the cylinder to move gradually instead of when you press it on. When you press the push button on, it just goes full mode. How can we make it to go gradually, like how machines work?
To move at a certain speed. Yes. Okay. So what we can do is we can add some flow controls. So I'm just gonna make this a bit, take this away for now, so we can make this a bit bigger so that you guys can zoom in on what I do. So what we can do is to make a cylinder move slower. Here, if we look at the pneumatics, we can go to flow control valves, because remember, if you control flow, you control speed, and we can bring in the throttle valve. Okay, so this is a one-way valve, a throttle valve, and we can. What we can also do with this is we can rotate it by using this icon at the top here, and then we can slot it in any position that we wish to slot it into. So in this case, let's say we're going to make this one slower. Moving forward, then we're going to add it in the line, and let's say view, fit to window, and simulate again to see what this cylinder does now. Okay, so if I'm playing it live, you can see it's quite fast, but now you can go and set your opening level. So I can drag and drop it here, or I can just type it in how much I want to open the valve or close the valve. If you do the basic pneumatics, we'll go through more detail regarding this component, but just for you to see there, now my cylinder is moving slower. I can also make it more slower, just to make it real slow. There we go. So it's obvious to see, and you have gradual slow movement. Yeah, I think that is the question, that answers the question. But if you do the basic pneumatics, we will show you how to do it, what to do and what not to do, because using these valves, there's rules to it. There are the correct way to do it, the incorrect way, and there are other ways, things that you need to consider and factors to consider when using these valves. Okay.
Charles, there's another question. Okay. And I think what I will do is I will actually do that for him.
Okay.
The question about the diagnostics icon. We will do the diagnostics. Definitely, we'll cover the diagnostics.
Yeah, okay, so guys, I'll just talk about it, but Darby will actually show you. Okay, so you can see this is a diagnostics drop-down line here, or menu here. Okay, so there's a failure configuration, And then there's also voltage, current, pressure, and flow. And then there's also your own instrument that you can set up. And that would be all underneath the diagnostics tool tab that you can choose. Okay, but Davi will take you through that. And when he does the electropneumatics, and he can show you more, because electropneumatics makes use of the electrical controls as well. Okay, Davi, so I'm going to give over to you now, and you can start sharing, and I'll stop sharing now.
Okay, good morning, guys, everybody. I assume you guys can see my FluidSIM. The FluidSIM software is open currently. I'm going to do the same exercise that Charles have done. Here I've done it now on the pneumatic side. What I've done is I actually already, where here I've used the pressure gauge, I've added myself a pressure switch. Let I quickly fit this into the library. I'm going to quickly there into the window. Say this is the window. That means I've added the pressure switch. Now this pressure switch is also part of my library. I'm going to open my library quickly. The symbol library, that's a standard library that you actually will have when you actually install this FluidSIM. It's underneath your pressure switches. There's a pressure switches, guys. Here's it. That's the pressure switch. All right. What this application is when there is a two cylinders A and B, like Charlotte explained. The first one, cylinder A, will hold the part in position by a pressure. That means this pressure needs to be built up, and this pressure, when this pressure built up, the second cylinder needs to go forward and it needs to draw. That means if the pressure is correct, the moment when the pressure is correct, then the second one will go. All right, what I'm going to do is I'm going to build the electropneumatic circuit with you. I've changed my valve already to a double solenoid valve. That means what he said, an MCV, a memory control valve. That means it's a memory valve with two solenoids. I've labeled the solenoid Y1 and Y2. Then my drilling apparatus, I've actually made it a Y3. I also have added my speed control already into my circuit so that it will slowly go forward. Okay, guys, I hope you can see me now. Sorry, I was actually for a moment forget about my video. Right, now that means on this, I'm going to build now the electrical circuit. That means I need to actually size this a little bit smaller so that we can actually move my pneumatic circuit in there. I'm going to quickly do now the electrical circuit. Right, first to start off, I normally go to page setup, drawing size, and I make sure that my drawing size is user defined. I'm not going to adopt to the drawing size, but the FluidSIM select when it opens. I'm use the user defined, and I make that wide and height 500 millimeters. That means I have enough space. Starting off with my power supply within my standard library, underneath the IEC. All right, I'm going to go to power, click on 24 volt, and I'm clicking on 0 volt. Get my 0 volt line. Okay, that means I'm going to copy this. I normally click here and I copy it. Right click there, copy, paste into it. Guys, I know there is a slightly delay within the demonstration when it comes to demonstrations. This is unfortunately not in our power to change it. It's because of the webinar, GoToWebinar software would actually have a delay in. That means I'm going to try my best to so that you guys can keep up with me. Right, then I'm going to do the same thing for my 0 volt. I'm going to highlight the 0 volt. Right click and copy that and paste it also into the system. Right, you can realize now that I've actually, it's like Charles have explained to you, you can flip or turn or rotating any component that you got put into your circuit. I'm going to click onto the 0 volt, go to that icon there on top, onto the rotating. I assume everybody can see the rotation, 90 degrees. Click onto it once again. There is my, right, then I'm going to connect the two lines. That means I'm going to connect my 0 line to the 0 line here. moved everything into position so that it looks like nice. The same with this. I'm going to click onto the 24 volt, connect to that side. Right, there I've got my 2 power lines now. You can actually highlight it and you can move it by hand down if you want to do it. All right, then let me assume now, because this is a small sequence circuit, what I'm going to do is I'm going to add myself another 2 power lines. You must also remember, I think if Charles actually also, you can go to tools, and here is what we refer to expert mode. The expert mode, when you put the expert mode on, look what happens. There's a lot of icons that's not there. The moment when you click onto tools and you go to expert mode, it opens a lot of other functionalities for you within FluidSIM. Yeah, and I know you will get used to all this as you start utilizing FluidSIM as a design tool or a presentation tool. Then you will learn all the menus like Charles actually also explained to you already. Now I'm going to go to lines. Here you can see here is contact lines. I'm clicking onto it. Right, it opened the properties of the contact lines. Please remember now there's pneumatic lines, there's hydraulic lines, there's electrical lines. I'm going to click onto electrical lines. Then I can also determine how much lines do I want to have. I want to have 2 lines. And let me assume I want them to be like, let's make it 10 millimeters from each other and say, okay, the moment when I say, okay, check what happens. Here it is. Now you hold your mouse in, click in, and you start dragging it. That means you can put it like vertical, or you can do it horizontal. I'm going to do it horizontal. That means this 2 lines is there for me now to move around. I can move it around with my mouse. Okay, right. Within this electrical circuit that we want now to automate is the moment when I press a push button. That means I'm going to go to the push button, go to switches, and go to the manual operation. There's my push button. Click onto it, drag it over into, right? And then, because we're going to make use of what we call now an indirect circuit, we need to make use of a relay, right? I'm going to go to relay, and here is my relay coil symbol, right? My component, I drag it into my circuit, connect it onto my 0 volt line, and I can also connect it now to my push button, and I can connect my push button to my power supply line, 24 volt line. Okay, now onto the relay. Very important to notice, the moment when I click onto this relay, I can actually go into, right there you can see now all the actually properties of this relay, and now it is selected for 230 volt. I'm going to change that into 24 volt. Right, I can also, if I want to display it, I can also the status of this relay. I like to say the status because the moment when I click here to display the status, it means that when I energize my relay, I can see it. Right, I'm going to say apply. Okay, that means there it is. I'm also going to click onto it again to go back into the properties. I want to label this. I want to label this. I want to label it. I'm going to go into it and label it again. This is my identifier. I'm going to make this R1 for relay 1, for example. Remember now, automatically it will be actually display my relay coil here. You can display it there, or you can actually give it a unique symbol or label, and you can display it also. And I say, okay, I want to, yes, I've also clicked on the display of the status. Right, there it is. Right, now my push button, and you can label also the push button. You can double click onto the component. It will open the properties of this component. I'm going to click it down there, put the PS. Not PSP, PSB push button number 1, for example, right? And I'm going to say, okay, so you guys can see it when I click apply. Okay, right, now that means, let me quickly shift this a little bit. It looks a little bit neater for me. I like it when even these straight lines. I can connect the connection also there. Okay, now what I'm going to do is the moment when I press my push button, I want A1, my relay A1 to energize, but Remember now, when we actually want to press the button, the operator don't keep his finger onto it. You need to press onto it. It needs to latches the relay, and as the relay latches with one of its own contacts, that means I'm going to go to switch, go to the switch, general switch, click there and drag it into this position. I want to add my latching circuit onto this, and then click here, right, there it goes. Okay, the moment when this happened, there's two lines that actually are on top of each other. That means I'm going to redo that part. Be careful when you do that. The moment when you want to test your circuit, you will see that it actually will give you problems. Right, it means now I need now to connect this relay contact onto relay 1. That means I'm going to double click onto it with my left mouse, click onto it, and it will open my properties of the contact. It's not a limit switch, it's not a roller switch, it's not a reed switch, but it needs to be actually attached to relay 1. That means the main component will be relay number 1. And I'm going to say okay. That means now the moment when I press my push button, my R1 will latches through there and I energize R1. Right, I'm also now, because of the coordinated rules, there is coordinated rules that we teach and present and help the people to understand the rules of actually creating a cascade system or a sequence. We call it coordinated rules. There's around about 6 rules that you need to apply when you design an electro-pneumatic circuit. That means what I'm going to do now is I'm going to go over to my contacts again, to the switches again. I want to go to the general switches there. There is what we call a changeover contact. Here's a changeover contact. I'm going to double click onto this. I want to change the rotation. All right, click onto it, drag it over there. Click on this one, drag it into position. Right, this will be now my power line. This line where I'm now currently is will be my power line. The other 2 lines is what we refer to with, according to the coordinated rules, we call this your control lines. This is your power line and this is your control lines. I'm going to click here and connect that to my power line. This will be to go to my first line. And the second, normally close contact, will go to my other line also. Right there. Now this relay contact need to also be attached. It needs to be attached to R1 again. I hope you guys can see it. That means the moment when I R1, I need to change my changeover contacts. Guys, I know there's a small delay. Please keep up with me. I'm going to double click onto this. I'm going to go to my main component. I'm double click onto it, open the main contact, and then I'm choosing R1 and say okay. Right, that means now this contact is actually attached to R1. Right, I also have added, because of my setup, I also have a tracing. Now the tracing can be done when you go to view and right here at you display contact image. This is part of the contact image. So when you do troubleshooting, it know that this 14 and 13 is in line 1, right? Sorry, in circuit number 1, line 2, and this contact is in line 3. That means the contact here is in line, there's line 2. That means it's line 2, circuit number 1, line 2. Then this contact is in circuit number 1 and it is in line 3. It means the moment when I click right here, show divider or show that means check here, there is actually, if I click that onto that and then go to this one, you will see here right on top, you can actually have a frame, or you can have that, or you can actually change everything you want to for your display into your system. All right, it depends on what you want to do. Okay, I think Charles also have explained that to you. All right, now to come back to this now, right, we already have allocated our limit switches. Right here on top is B0 and B1. That means when I press my start button, when I press my push button, I want R1 to come in, and the moment when R latches through here, but part of my circuit, it will be that B0, the limit switch B0 need to be closed. before. It needs the drilling apparatus need to be in the back position, all right, before I can clamp the part and before this one can go again. That means I need to use my B0 width into my start line. That means I'm going to click on this and drag it over to this side. I need to normally close, right? Why do I need to normally close? Is because B0 must be actually normally closed. The moment when it opens, when B0 opens, I'm going to make this B0. Check what I'm going to do is click here, right click here and go to B1, and say, okay, this will be B1 because I'm going to make this a roller lever limit switch there, a roller lever limit switch. I'm going to add that into my first line. Right, let me quickly add it into this line, click onto it, drag it into position. Right, look what happened there. Let I fix that problem. All right, let me click onto this, open that line, then move it into position. All right, let me do it like this, connect it there, and connect this one also to that point there. Okay, that means now in my circuit, let I lift my circuit up a little bit. Right, I assume everybody can see it, Charles. Okay, that means now the moment when I press my start button, my B1 will be closed. I will energize R1. R1 will latches through, and it also changed my contact. That means the moment when I press my start button, I want Y1 relay, not a relay, sorry, my solenoid valve Y1. I need to go and get a solenoid valve into my, right here is a solenoid valve. Right there is my solenoid valve within my library. I need a Y1. I also need a Y2. I also need a Y3. Right. Now I'm going to connect on my first line. That means the moment when R1 energizes, it will switch over to 24. That means I will power this line. That means this line needs to be connected onto my there, and this is go onto my 0 line, 0 volt line. Okay, and the same with the other relays. Not relays, solenoid valve. Sorry, guys, there it is there. Okay, right. It means now I'm going to now label this also. The moment when I click onto this, I can go to my actually identification. That will be Y1. Okay, I'm going to do the same thing for this one. All right, I assume you guys can see it. Right, then Y2, and then double click onto this one, and also do a Y3. Right, it means now, guys, the moment when I press my start button and my first cylinder, that means cylinder A, start moving forward, the pressure will build up. And as the pressure builds up, all right, I want B to go forward. That means that is the Y1. That means I need now to take electrical circuit, electrical symbol of the pressure switch also within to my control. All right, it means I'm going to go now to this one, go to measuring, and here is my pressure switch. I'm going to pull my pressure switch in there. This is what we refer to. The moment when I click onto it, you can click onto it within FluidSIM. You're highlighting it, and you can go to didactic on top there to the didactic, and you say component description. You can click onto it. What happens is the moment when you click onto it, this is the pressure switch. And give it a moment, it will be there now shortly. Right, the moment when you click onto it, you can go to didactic components, and you can see what the component looks like. All right, I'm going to close this again. Right, it means, look what happens. The moment when I click onto the pressure switch, I highlight that component. Then I'm going to didactic. It's a component description. I click onto it, and I'm waiting for the system to react, and it will show me what the component look like. It will show me how the component, there will be a picture or a working principle of the component. That means You don't need to struggle, or you don't need to wonder what is going on or what it is all about. You can actually utilize a lot of the functionality within FluidSIM that can help you to understand how the components works. It means that this makes life so easy when it comes to actually designing a circuit, right? And also the moment when this pressure comes in, I need to make sure that Y3 is in. I also need now to label this according to, attach it to the pressure switch that we used right here on top. The pressure switch, I need to make sure that this pressure switch are linked to the pressure switch there. Double click onto this again, go to and say, right, PS1, pressure switch number 1, and say, okay, now I know the moment when the pressure switch comes on, Y3 will come in and Y3 will start moving forward. Right, now as it goes forward, it reached B1. All right, now check what happened. The moment when it reached B1 will open within my start circuit. And as it's opening in my start circuit, right in the start line, what will happen is your latching part will fall out, and the relay number R1, the relay R1 will then change contacts from the normally open to the normally closed, back to the normally closed. Then you will power this line. That means now that you don't have, then you need to have actually Y2. But important to understand this now, right, is I cannot actually send my cylinder A back if I did not reach the rear end of the B cylinder. That means B cylinder need to be in the rear end before my A cylinder. That means before I unclamp the part. That means before I unclamp the part, I can actually need to be, the drilling apparatus need to be in the rear end position. That means I need my B0. Right, B0. That means I'm going to add myself now a contact again. Go to the switch, go to the make switch, bring it over to this side. You will see that I'm using a make switch because the moment when your system realizes that this is actually part of my circuit, it will actually, what we refer to as, it will actually bring up a sign or a symbol that shows that B, because I need to attach this now to B0, double click onto it, make it B0, check what happens, B0. The moment when I say okay, check what happens. The moment when I do this, it shows a symbol right next to it that show now that arrow that showed it upwards, show that it's now actuated. Why is it actuated? Because my cylinder is B. Cylinder B is currently in the back position. Okay, there is my circuit. That means now we can test the circuit. I'm going to go to view and fit it to the window so that you can see everything. There's my, right? Okay, now I'll also need to make sure that my pressure, the moment when I click onto my pressure switch, I've set my pressure switch for bar. All right, give it a moment. You can see it now. I've set my pressure switch for bar, all right, the unit. I also set now when it reached 5 bar, all right. What I can also do then is to make sure that I can go to my pneumatic side like Charles have done it is, I went into my actually pressure control, right? Or I can go to the flow control, right? I don't need that. Supply, I need to now a gauge, a pressure gauge. Okay, let me quickly see this. Measuring, okay. Here's a pressure gauge. I'm going to put it right here on top there. Right, click there and move it into position, connect it so that I can see what is the actual. What is the actual pressure? Like I've explained to you, when I click onto the pressure switch and I'm going to the diagnostics, not diagnostics, sorry, the didactic component, you will see that this switch got your own onto the pressure switch, onto this pressure switch. It will show it to you now. Give it a moment, give it a moment, give it a moment. It will be there. You can see on this pressure switch already we got a LED screen, right? That will show us the indication or give us an indication what the pressure currently is on this pressure switch. Okay, but because I want to see the manual one, or locally, if I can call it like that, I also want to see the pressure. I'm going to click onto this one and make sure that it is also in bar. And okay, right, the moment when I put my, after that, I'm going to put now my simulation on. Click on my simulation, all right. And as I press my start button, the moment when I press my start button, then my cylinder goes forward and my drilling apparatus go forward. It touches B1. And now it comes back. And the moment when B0 is there, it will actually then go back to my rear end. And that's how you will automate it, your circuit, your drilling apparatus circuit, as within electro-pneumatics. Right, guys, this is now electro-pneumatics. And now I want to show you also the diagnostic part if you want to test it. Now, what you can do is, I'm going to go quickly off from the simulation mode. Right, you can go to here is what we refer to a voltage, a current, a pressure. For example, I can click on this now and I can drag this over here, but nothing will happen. I need to be within the simulation mode. That means I'm going to click onto that thing there. There it is now. Click it, right click here and do it there. That means I can see what is the pressure. I'm going to see also here, right, is what is the voltage. Check. I'm going to click on that one and go to here. Okay, give me a moment. Okay, and then I'm going to do this. Click onto this one. Check here. Click on it. There's my red line. And then click onto move it into the position. Sorry, guys. I can then see also what the voltage is, right, over my relays. And I can also, guys, click on this one for the flow.
Sorry, I think we must just mention maybe that is a voltage meter that they just, because some guys do not have electrical background. So that's okay. A voltmeter, guys, that we are using currently. Davy also is going to use other meters as well. He will just show it to you and explain to you what he's using as well. Thank you.
Thank you. Guys, look, what I've done is also, I've done the voltage one. Voltage. A current. I can also have the current one if I want to. For example, let me see, you want to measure the current on this one here, right here. Then this is the pressure one. I've done the pressure for you already. And then the flow, right? I also have done the flow here, so you can see what is the flow, right? And we set now liters per minute, all right? There's also an option, when you go to diagnostics, right? And you want to show the diagnostics tool strip, and that is what I've said here. When I click onto on tools, and I go to expert mode. All right, if I want to go to diagnostic, show that to me, you can click onto it, tools, expert mode, and there you can see all the other lines also. That means, right, now what you can do also, I want to ask Charles to do that for me. If you want to simulate a fault, right, Charles, will you please do a simulation fault when you finish off with this presentation?
Okay.
What I'm going to do then is, guys, now I've done the electro-pneumatic circuit. Now I want to replace this. Let me assume now you want to replace the fluids, your electro-pneumatic circuit within your FluidSIM with a PLC. All right. Now, to save a little bit of time, what I've done is I've built a circuit, and like Charles, I've mentioned that he actually built a library. I'm going to go to my online FluidSIM free webinar library that I've created myself. I can then take this one and move it into my library again, put it into my library, for example. I can call that circuit number 1, 2, 3, 4, for example, and say, okay, I'm going to delete this circuit now. Right, now I want to control my electro-pneumatic circuit with a PLC. And I've done that PLC part for you already. That means I'm going to click onto this in my library. In my library, I'm going to drag this over and put it into my circuit here. Okay, and I've done a lot of things here right into this now. All right, let me just move everything so that you guys can see everything. Let me move that a little bit up also. Let me do it in there. I'm going to highlight everything like this, move it into position. All right, I assume everybody can see it on the same screen. Okay, guys, now this is coming also from my libraries. Let me quickly go to the libraries. Right, I'm going to go to my FluidSIM standard library. In the standard library, like Charles already have mentioned to you, right here at the bottom, there is your digital technology. Digital technology. That means in my digital technology is logic modules. There is one with 8 inputs and 8 outputs. Right? Then there's also one with actually, like I can pull in, click onto that one, drag over to this side. Then you can also have a lot more, right? You can have then also 16 inputs, 16 outputs. That means you can have, actually, when you write a program or you want a program that works with, 16, that means a word or a word input, that means 2 bytes. The same with the output bytes. You can utilize that, or you can either use this one that actually have, like I said to you, the 8-bit one. Now, this is what I've used. I've used now the 8-bit one. Okay, I'm going to delete that part. Right, now how do we start filling in your program? Guys, now listen to this. Again, what I need to do is exactly the same what I've done onto the electro-pneumatic circuit. I've added myself a 24-volt line, a 0-volt line, a 0-volt line. I've attached my push button, all right? I've attached also my B0. You can see B0 is there, according to that B0 there. B1 also. I also attach my pressure switch that is actually linked to that pressure switch there. I've got my Y1, Y2, Y3. All right. Now, if you want to start writing the program, that means you want now to do your logic part. I'm going to double click onto the module, double click onto the module. It opened the component parameters for me. Now, I've done a program already, but how do you edit or how did you edit the program? You go to editing mode, click on editing mode, and it will open the editing mode for me. Okay, this is the editing mode. Okay, right, don't worry about this now. I will check. I don't know why that is there for the display for some reason. Okay, now guys, this is now my program. Now, I've added a timer also into it. I want to quickly show you. I'm going to take the timer off, delete my timer, right. That means now this line is actually directly connected to, okay, for some reason this stuff is there. Guys, give me a moment. We want to go back here. I'm going to delete that part. Give me a moment. Quickly want to go back into this so that that thing is not bothering me. All right, I'm back into the PLC program, into the where I edit my program. Okay, guys, now listen to this. I can actually now, if I want to display, let me assume you want to test or simulate your circuit if it's working. You can go to Windows. Like any other Windows-based program, you can actually also view your Windows vertically. There I've got it. I'm going to close my library a little bit more, open my circuit on this side. All right, let me quickly go back into editing mode. Come on, and right, go to Windows and then vertical. All right, now I've got both my circuits. All right, let I shift my circuit in such a way that everybody can see what I'm doing. All right, let me shift this a little bit closer to that side and close my windows. Okay, I'm going to move this window into position so you can see both my circuits. Okay, okay, I'm going to do it like this for you. Okay, let me do it like this. I'm going to switch on my simulation package. Okay, right. That means now, look, there's already some things that's alive on my program. The moment when I press my start button, there my PLC program actually will act according to what my philosophy is, and then it will go back. That means now, guys, and there it goes. Exactly the same circuit that we have built onto the electro-pneumatic is bolted now into my PLC. Right, now there is something very unique about when it comes to, I'm going to close this circuit again. I will add the preset of the timer now for you. Okay, open this over. Guys, look at this. Here's all the components. Right, now I must be honest with you. This PLC, or this relay logic PLC. This is a relay logic PLC based onto the Siemens logo. That means the Siemens logo. All right. That means all the functionalities that's built into FluidSIM, all the components, what we call function blocks, are actually part of your logics into the logo PLC of Siemens. Then I can also go over to GraphSet. Now, guys, GraphSet is also very nice. You can also utilize GraphSet. It's like FlowGrader. But what Festo have done is they have added a FluidSIM. Then they called it an easy port. Now, guys, they call it easy port. Now, I'm going to show it to you on my screen. I will bring in the photo for you. Sorry, I will bring in the photo for you. Give me a moment. Give me a moment. I will bring it in. Guys, I assume everybody can see my screen now. This is what we refer to as our easy port. Now, this cable that runs here can go to a distribution box, or it can go to a simulation box. That means this cable can be connected to a distribution box that we wired physical inputs and outputs. That means hardware into that. That means this easy port connects the software to your hardware so that you can utilize the PLC within FluidSIM to run a real actual hardware. That means if you buy this from Festo, the easy port, you can connect to the hardware. You can run the hardware from the simulation. That means the moment when you press your start button, but I'm going to show it to you, and this is what I've done. I'm going to show it to you. What I've done is I've added already into my circuit. I already have done in a FluidSIM the easy port inputs and the easy port outputs. Right, you get it from here. Right here right. Sorry for this now. I'm going to quickly stop it. Click onto FluidSIM. There is my FluidSIM analogs. FluidSIM, actually, there's my FluidSIM inputs. All right. I can also have the fluid outputs, right, for the easy port now. And same thing with the analogs also. Now, what I've done is I've already add this component into the 8 inputs, right? That's part of my easy port here. You can see my easy port. This cable have 8 inputs and 8 outputs onto it. I've connected now that. Now check what happens when I simulate it. I'm going to quickly take this off here for now. Delete that part. Okay, and I'm going to go back into the simulation mode. Right, I will be shortly finishing with this now. Guys, now check what happens. I'm now going to go and on my camera, I'm going to show you my simulation component. Check my simulation component. There's my simulation component. I'm going to go to my bit. Check what happens on my, right, the moment when I switch on, when I switch that bit on, I'm actually connected to input 1.7, and I also actually can run it. Because what in my program, what I've done is in the program, I say double click onto this. I've said now I'm running to an OR valve here, to an OR valve. It's the input 0.1 or input 1.7. Okay, that means it's either this one that's coming from the simulator, the easy port simulator, or it comes from my push button here. I'm going to stop it, take it off. All right, and now that is the FluidSIM. That means FluidSIM connected to an easy port can actually control real hardware also. That means you can utilize the FluidSIM as a PLC to actually operate hardware. I think that's my story, Charles. I think you can take over. I'm going to stop sharing.
Okay. Okay, thank you. And there we go. Okay, I'm sharing. Just make sure you can see my screen, everybody.
Okay, thank you, Charles. Okay. We can see your screen.
Okay, thank you, guys. Okay, so just to go over it again, you can also, once you have a project drawn, you can actually add a drawing frame. Okay, the drawing frame you actually get from tools, and you can go say manage drawing frame, and then you can go and pick a frame that you would like to insert on your drawing. So for the project managers or the guys making the drawings, this is your choice which drawing frame you would like to use. Then, as Davi also showed you guys, there are dividers and rulers that you can add, and you need to make sure each line has got its own divider so that it gets that number. So number 1, this is divider number 1, this line. Line number 2 is within divider number 2, and you can move these dividers up and down, up to you, but you need to make sure that is correct if you want to send it to a client. Okay, and then the next few things also, remember you can also add bitmaps or Festo. If you work for Festo or have Festo components, you can also add some images to your system, to your drawing, and then you can also add contact images as well as terminal images, and also on the contact on the circuit cell diagram itself. You can see that there's certain numbers there. I can add it or take it away. So it depends on how clean you want your circuit diagram to be. And then you can also simulate. And then what's good about it is while it's in the drawing frame, you can actually, when you simulate, you can actually pause it and send it to a client at a certain position. So the cylinder 1 moves forward, then cylinder 2 will start to move forward. And we can actually, let's say, there we go, we stop it, we pause it, and now we export it as is. So you can actually, if a client says there's a problem on this or that happens, or that this happens to that, then you can send it in that position to them on a drawing frame and tell them, please look here or look there for the problem, to find out where what the problem might be, and that would also assist them, and you could assist them to find the fault from far away. Okay, so then Davi also mentioned you could also work on failure configuration. You can add a fault to a system. So basically, I already added one. So yeah, if we go to configure a failure configuration, that is now basically under the diagnostics. Yeah, so if you say manage failure configurations, then it will open all the faults. So if you want to add a new fault, you can say new, and then you can go pick what you want to cause a problem on, and you drag it to the right hand side, and then you say what type of problem do you want to simulate, and then you can also set the parameters of that fault if they are available, and then you can just say, okay, but I'm not going to create another one now. For now, I already created one, and this is, I just called it A. It's on cylinder A. It will have a problem of internal leakage, and that means my circuit would not run as it should. So what I'm going to do is I'm going to run it as is, without the fault, because there's nothing in the fault line here now, the failure configuration. Okay, so I'm going to start it, and we can automate it. Okay, so there we go, cylinder moves forward, and then so once it reaches A1, then B will move forward, If it reaches B1, and then C will start to move forward. When C moves forward, it brings the 2 back, and it repeats. Okay, so that's basically the sequence there that we see there. So what we're going to do now is we will add the fault. We're going to add it, and we will simulate it again. But now you will see immediately, once it starts to simulate, it will tell you there is a problem now. You are simulating one of the faults, and it will tell you what fault you are simulating. So now if we run it, and let's put it on auto again, let's see what happens. Okay, there we can see it doesn't return. This cylinder, it's got an internal leakage. All the air from the left-hand side to the outlet, there's an internal leakage through the cylinder, and that's why this does not come back. So we can complete our sequence. So that is basically how you simulate the faults. I know we are quite fast on this webinar, but when we actually do the course, and then we will follow us step by step. Okay, so remember, you can add images to your drawings, and you can also add the bitmap Festo and some other diagrams and terminals and other tables and maps. You can see under insert, you can go and choose what you want to insert, and you can insert it into your system, and then you can just export it as is. Okay, then also obviously the contact images, you can also go to view, and you just go and click if you want to see contact images or not. Okay, so that's really available. Then also the last thing is, yeah, you can also pause and print like I showed you, which helps a lot. And then also, like Davi already showed you, you can use the pressure, voltage, current, and flow in the simulations, diagnostic tools to actually simulate and see what happens, as well as remember the dividers. Okay, guys, so who should use FluidSIM? It's basically yourself, your clients, panel builders and staff, project managers, stock controllers, procurement managers, technicians, draftsmen, maintenance teams, and full service technicians. So basically for the maintenance teams, you can use this for preventative maintenance if you have old machinery, and you can also charge other clients to actually design these circuits for them if they do not have circuits for old machines. So that's an add-on. So guys, this is everything that we wanted to show you this morning regarding FluidSIM, and just to introduce you to what you can do with FluidSIM. And obviously, if you do the course with us, we will take you. You will follow us step by step. So I know we were running as we went along, but it's just to show you what you can do and the power of FluidSIM. So are there any questions from you guys that you would like to ask now before we close the meeting? Anyone? I do not see any hands up. I'm not sure, David, have you seen any questions? Yes.
No, there's no questions on my side. What I want to ask you to maybe give them the handout so that they know what the courses is that we're going to run in the near future for next week, and where do they need to go and register, or where can I see the link for this video?
Okay, yeah, I do not have the handout with me. I will ask Hannes maybe just to send it out then to them. Okay. I do not have it with me at the moment. Yeah. Okay. So yeah, are there any questions, guys? I see there are a few guys here. So are there any questions from your side? Michael, I think you asked a question, but I think we already answered your question. Yes. Okay, so that was the question we had this morning. First of all, the diagnostics icon. Okay. And the table, that was the two questions that I can see. Okay, guys, if there is no more questions, then we're going to close the meeting or the webinar, and we will see you as soon as you register for our courses. And next week, we will actually do the basic pneumatics course, and then every week after that, there will be a course also running as we go up.
There's Michael that asked now, how much does the full training cost? I assume for FluidSIM, or is it for basic pneumatics or electro-pneumatics?
Okay, any basic course or any of the courses based on, let's say, a 4-day course. Oh, FluidSIM. I'm sure I'm not sure on that one. All the others are say around 750 Rand. But for FluidSIM, I think just speak to Hannes. He might, you will be able to help you with that. That exact price, because that's a half day to a full day, so it's not a 4-day course. But because in a half day to a full day, we will be able to show you everything you need to know, and then you can follow us and copy and paste and do what we do. Okay, I hope that answers the question for now, but please speak to Hannes and on hannes.otto@festo.com. So that is basically his email. If you want to ask more, then just email him so that you can get current prices of the half day or 2 hour 1 day webinar for FluidSIM. Davy, are there any other questions?
Nothing. It's only the price. Michael have asked about the price for FluidSIM. Yeah, that's
okay. And then the FluidSIM, if you want to buy FluidSIM as a package forever, it's a once-off license. It's not like AutoCAD that you have to renew your license every year. You pay it once off. Then it's well, on the South African side, it's between 20 to 25,000 rand roughly. That's for the first license. Every time you buy a second or third license, for every added license, you pay less and less and less and less. So it depends on what you want to do, obviously, with FluidSIM. Usually what I recommend is that workshops or workplaces get 2 of them, one on a laptop and one in the workshop. So that one on the laptop can go with the technicians when they work on the floor, or a field service technician, if he might need one, then he can take one with him on his laptop. And then also to have one always left in the workshop to simulate new systems or new designs, or maybe some fault failure configuration simulations to see whether they can figure out what went wrong. Okay, so that's that's what I have to tell you guys today. If there are no further questions or anything else, then we will close now the meeting today. Okay, any other questions, guys? Davy, is there anything else?
Nothing. Everything is there. I've sent Michael Hannes' email.
Okay.
Hannes.otto@festo.com.
Yes.
I think you can actually request a quotation from him.
Yes, yeah. I think that would be
Okay.
get it from.
I'm finished on my side.
Okay, guys. Thank you for coming. Thank you for joining. We will be closing the webinar now, and we hope to see you on our basic pneumatic course, basic hydraulic course, our electro-pneumatic course, PLC courses, and then also later on the sequences course, where we can show you more about how to design sequences properly. Okay, thank you, guys. This is all good, and we will see you again. Thank you very much.